looking at the trigonometric ratios homework, and we are doing number 14 to start with. We know that to use trigonometry, we have to know two pieces of information, two sides or a side and an angle. So if we look at this triangle, we do note that it is isosceles, and that's great because that means that that is not only an altitude, that's an angle bisector, it's a median, it's all of the above. So that's good news. Once we find this side right here, all we'll have to do is double it to get y. Let's go ahead and find that side first. Let's call it z, x, y, and z. All right, so we're going to zoom in, and we're looking only at this right triangle right here. You can only use trig on right triangles, so don't try to use it on, like, let's say that acute isosceles triangle. All right, so compared to my angle, z is adjacent, and 11 is the hypotenuse. So we're using the part of SOHCAHTOA. So we are choosing cosine. The only thing ever allowed in parentheses is the angle, so you put the angle in parentheses. Then SOHCAHTOA says to put adjacent over hypotenuse because it goes in order, adjacent over hypotenuse. Then you ask yourself, where is the variable? In this case, the variable is in the numerator. When it's in the numerator, you multiply, and when it's in the denominator, you divide. So in my calculator, I'm doing 11 times cosine of 69 degrees. As long as you are in the right mode, you'll get 3.94. But I have to remember that that's only half of y. So I'm going to take that number and I'm going to double it. And we get y is 7.88. Now to find x, we're going to use those same numbers. We're going to recycle them. We're going to use them again. So we're going to use the angle and we're going to use the 11. Compared to my angle, this x is opposite. This is opposite. And 11 is still the hypotenuse. So that's the so part of SOHCAHTOA. So I am using sine. The sine of our angle equals opposite over hypotenuse. X is in the numerator again, so we're going to multiply again. 11 times sine of 69 degrees, and we get that x is 10.27. When we round, that 9 bumps the 6 up to a 7. All right, let's move on and look at number 18. Number 18, remember, you have to use trig on a right triangle. Let's find x first, because that is the easiest one to find. So, remember, we're standing at x. This is where we are, right here. Compared to our location, what's 18? It's opposite. And what's 27? It's the hypotenuse of the triangle. So to solve for x, we are using sine. The only thing allowed in parentheses is the angle. You don't put the side, you put the angle there. And then you do opposite over hypotenuse. Now, you ask yourself, where is x? Well, x is in the sine function. The only way to undo sine is to press second sine. That's called inverse sine. Sine to the -1 of 18 divided by 27. So second sine, 18 divided by 27. You get 42 degrees because we are rounding this to a whole number. We generally do that for angles. Now, what we're not going to do is assume that this is an angle bisector. We are not going to do that. So we can't just find that angle and divide by 2. Instead, we're going to look at this triangle right here. To do trig, you have to know two things about the triangle. We only know one thing. So we better find something else out. So what I'm going to do here is I'm going to find this side right here. I'm going to call it, I'll do z again. Once I know z, I can divide it by 2, and then I can work with that pink triangle. All right, so to find z, I would go and use Pythagorean theorem. I wouldn't even use trig. So I'm going to find that missing side by doing 27 squared minus 18 squared. That's hypotenuse squared minus leg squared. I'm going to take the square root of 405, and I'm going to get 20.1246. Now, because I see these tick marks, I'm going to take that number and divide by 2. 10.06. So this side length right here is 10.06. I can keep some extra decimal places if I want to be more exact. All right. working with this little right triangle right here, this one right here, and I'm trying to find y. Compared to y, what I just found was opposite, and the 18 is adjacent. So look at us using all sorts of trig functions here. The tangent of, you have to put the angle in parentheses, the tangent of y equals opposite, well, we just worked hard to find that, over adjacent. So we're going to do second tan 10.0623 divided by 18. And we get it is a 29-degree angle. So lots of trig going on in that one problem. That was a good one. The last one I'm going to do is 26. It's not a hard problem. You might just have been confused about the wording on that one. Find the acute angle measures of a right triangle with hypotenuse 25 and leg 7. So it's really just asking for these two angles. It's asking for the missing angles. When you have a right triangle and one of the angles is already 90, then the other two left over, they're both acute angles. That's what it's asking for. Just choose which one you're going to look for first. So if I'm looking for y, I've got opposite and hypotenuse. Sine of y equals opposite over hypotenuse. And you press second sine. We would do the same thing for x, but now it would be the cosine. The 7 is adjacent and 25 is the hypotenuse. So if I do second sine, 7 divided by 25, I get 16 degrees. And I could just subtract that from 90, or I could do second cosine 7 divided by 25. And I get 74 degrees. You should always check these two should always add up to 90 degrees.